Hey guys, in the last episode I said I would be looking at enemy instantiation for the next one, and I decided to change my plans, which means that today we're going to talk about towers instead. I realized that instantiation is a huge chunk to deal with, it can be very heavy, and at the same time it doesn't provide much because if you don't really have a tower to despawn the enemies that you do spawn in, it's not really useful. So instead we will be dealing with the towers and see how they can detect enemies. For this episode I brought two new textures. So we basically have a tower socket and a tower icon. So I want to keep this very simple at the moment. I really don't want to spend too much time on making super fancy assets. That's not really the point of this series. Here we're focusing on programming. So let's create a new 2D scene, which I'm gonna name Tower 2D. We can save this already. Enemy world, okay. So Tower 2D. Perfect, and save this. Okay, so pretty much just like the enemy, we will have a sprite to display what the tower looks like, but more specifically here we will have two sprites. So I'm gonna create a sprite 2D, and I will duplicate it so that we can have the tower socket. And here we're gonna have the tower sprite. The name of this node is probably not gonna be very important. So here, let's bring the socket in there and the tower sprite in there. The point of separating the tower socket and the tower sprite is to basically create a kind of base structure that we can create and then apply different kinds of towers to it, kind of pre-positioned towers. Let's actually go in a world and position the tower we just have created. So we're going to drag and drop here the tower 2D, and we can move it around to put it around this top left corner. It's going to be okay. So the point of this episode here is to actually see how a tower is going to be able to detect an enemy. This means we have to do some work for both the tower and the enemy for this little system to work. Let's start with the tower. So here we're going to add an area 2D node. The concept of an area 2D is to define basically, well, the name says it, an area which will be drawn with collision shapes. So basically in and of itself it does nothing. It requires a shape, basically collision shape. So here we're going to use the collision shape node, and we're going to select the circle shape. To make this kind of clearer, I will make it yellowish. Yeah, something around here is going to be okay. And then I will make it bigger by actually selecting the circle shape results here and changing the radius to 200 pixels, maybe 250. So if we save this and go back to the world, we can see the range of action of the tower. Okay. So now we're going to do the same thing, but for the enemy 2D. So here we're going to create an area 2D as well, and we're going to add a collision shape, which is going to be a reddish circle. Red's around here, something dark, and we're going to create a circle, yes. So it's up to you to choose if you want it to be bigger or smaller. I think smaller here is going to be fine. Anyway, now we can see that all the areas are visible on our world. So what is the point exactly of creating areas for both the tower and the enemies? Simply, we will be able to use the node signals. So here let's look at the area 2D in the turret, for example. If we look at the signals, we have a few things like area entered, area exited, and body entered, body exited. This is quite useful because this will allow us to tell when an enemy area is entering in the range of the turret, right? So we can rename this range area 2D, for example. So before we jump into the coding of this, let's actually talk about collision layers. We can decide on what layer of collision our area is existing. So for example, to make this a little bit clearer, we may have a layer which represents the physical spaces on the map, which will allow us to define where the player can build a tower or not. And then we would have another layer where we would be displaying the enemies. It's kind of, each layer is going to define a different kind of things you want to detect. So here what we will do basically is that we will use the first layer as the layer for the enemies. So we're going to right click this layer 1 here and rename it enemies. So we have 2 categories and a few numbers. When we click on a number, we will toggle whether or not this collision shape is existing on this layer. And we have 2 things, the layer and the mask. So the mask is kind of the reading attribute of the area, and the layer is the existing attribute of the collision shape, the area. So here the tower will be monitoring enemies, so it will exist in the mask of the enemies layer. Meanwhile, the enemy will actually in its area 2D. Here, it will just exist on the layer, but it will not be monitoring anything. So we can untick monitoring, and here tower we can untick monitorable. Okay, so now we will take care of actually having the tower detect when an enemy is entering or leaving its range. For this, we will be using the signals area entered and area exited. All right, so let's create a C# script, tower 2D, let's go. All right, so the empty class is here. So first what we will do is to create 2 functions which will be receiving the signals, the 2 signals. So we can try to do that without me, since it is quite an echo of what we did in the previous episodes. Otherwise, let's go. We're gonna have a public void on area entered, as well as a public void on area exited. Here in our connection, we actually need to reach the area, range area here. So we could, as usual, use the export, and I think we will be doing that. Okay, so let's do that. Export. I don't think it's necessary to complicate things. So we have area 2D, and we're gonna have, I can say range area, actually. It's gonna be okay. And here we will say that range area dot area entered, and we will connect on area entered. Okay. Yes. So here we have an error, and the error basically comes from the fact that the signal area entered has an argument. So it is actually necessary that the function which receives the signal reads and processes this argument. So we're going to say that we have an area 2D here, which is going to be the argument area. And we're going to do the same for the other one. Here we're going to have the argument area. So now we can connect the second one, range area exited, plus equal on area exited. All right. So let's make things simple and just say that we want to print when, enemy left tower range. Actually, I don't need the cap here. It's actually not left, it's entered. But anyway, GD print enemy left tower range. Okay, good. So this is pretty much everything we have to do for the tower. Okay, now go back, build our game, and see that the tower now allows the connection for the range area 2D. We can assign the range area 2D. Correct. All right, so let's actually try the game right now. So technically nothing should happen because nothing exists. No enemy is within the range of the tower. However, if we do, for example, move the tower here and one enemy in the area, and we do now run this current scene, we'll see that an enemy entered the tower range. So at the moment, since we have a little bit of time, we can try to actually have the enemy move around to see exactly when they enter or leave the area, see how the tower reacts to this, and yeah, confirm that everything's fine. I'm gonna move the enemy number 3 around here, and we're gonna add a little bit of behavior to the enemy. Let's actually make this an exercise. So what I want you to do here is to actually make the enemies move toward the left side of the screen, which is inverted with the camera, so that they enter the tower range and then they do leave the tower range, and well, they will leave the screen as well, but that's not really a problem. Alright, so I will let you do that. And now we're going to explain how we do this. It's actually quite simple. All we have to do is to override the process method. So if it is your first tutorial, then that's alright if you don't know that. It's just like one of the first things people do research online. Anyway, basically the process function will proc every frame of the game, and we will have a delta function which will tell us exactly how much time elapsed. Now that I'm thinking about it, because we're dealing with the kind of enemy movement, I will not use the process frame, but the physics process. So here I'm gonna override the process, but the physics process. So here, what we will be doing is updating the position of the enemy based on the elapsed time. So let's create a move function, okay? And we're gonna send a float. Actually, let's make this a double. Well, then we'll just send delta. So here, public void move, and it takes a double delta. All right. So in C# there is one thing we can't really do if you've been using GDScript, so maybe that was a problem for you. You can't just say that you take the position x value and you assign it a new value. This doesn't work. So let's create a new value. So we'll create a float, which is going to be new x. And this is going to be equal to position.x plus equal delta multiplied by something like 120 plus equal, actually just plus. And here we have a slight problem. The delta we're using actually requires to be a float. So we have a few options here. We can cast everything as a float by using a float keyword in front of delta and a float f after 120. Or we could change the argument. That's totally up to you. But the point is, yeah, this is the movement speed. But anyway, now we have a new x. So all we have to do is to actually create a new position. So position is going to be equal to a new vector 2, and its value are going to be new x and position dot y. Let's actually run this world scene. It's not correct. I actually completely forgot to think about the direction of the movement. So you just change the movement toward a negative x, and there we go. There we go. So enemy enter, and then we will have enemy leaving one by one. All right. So we already spent some time on something which is not going to be used in the future. So we're going to stop the episode here. But if you actually want to train a little bit more, something you can do is actually make the enemy bounce on the edges of the screen. If you can manage to do this right now with everything we've seen, it's possible. You will just have to be creative, but I do think that we have seen all the tools you will need for that. So if you want to try this, it's actually kind of cool. And if you achieve this, then let me know in the comment, because honestly, I'm trying to understand what is my viewership here. So if you're that kind of person who likes to explore by themselves and see what they can do and experiment, then I'm curious about knowing that. Anyway, that's all we will be talking about in this episode, because in the next one we will be talking about having the tower attack. So yeah, pretty cool. I hope you're excited, because that's kind of a big step. And I will see you there. Until then, you can think about liking the video, subscribing if you did on this kind of thing. Also, if you want to help me find the episode and get them early, you can become a member of the channel. Or you could also join the Discord if you wish to ask questions and get in touch with our community. Always appreciate it. So you take care, and I will see you in the next video.